Antarctica, the last true wilderness on Earth, has long been considered an isolated paradise. Its icy landscapes and pristine waters, home to a unique array of wildlife, have captivated explorers and scientists for centuries. This remote continent, once thought to be untouched by human activities, is now revealing a disturbing truth. Recent scientific studies have confirmed the presence of microplastics in Antarctic waters and even in the ice. This discovery has sent shockwaves through the scientific community, raising serious concerns about the far-reaching impacts of plastic pollution. The presence of these tiny plastic particles in such a remote location serves as a stark reminder of the pervasive nature of this global crisis. The discovery of microplastics in Antarctica is a wake-up call for humanity. It signifies that even the most remote corners of our planet are not immune to the consequences of our actions. This sobering realization underscores the urgent need for collective action to address the plastic pollution crisis before it's too late. The groundbreaking discovery of microplastics in Antarctica was made by a team of dedicated researchers from the University of Oxford. Led by Dr. Alex Rogers, a renowned marine biologist, the team embarked on an expedition to the southern ocean surrounding Antarctica to investigate the extent of plastic pollution in this remote region. Dr. Rogers and his team, driven by a shared passion for conservation and a deep understanding of the interconnectedness of our planet's ecosystems, meticulously collected water and ice samples from various locations around Antarctica. These samples were then transported back to their laboratory in Oxford for analysis using advanced microscopic techniques. Their findings, published in the prestigious scientific journal Environmental International, revealed the presence of microplastics in every single sample they collected. This discovery sent shockwaves through the scientific community and served as a stark reminder of the far-reaching consequences of human activities on even the most remote corners of our planet. Microplastics, tiny fragments of plastic less than 5 millimeters in size, pose a significant threat to marine ecosystems. Detecting these microscopic particles requires specialized techniques and meticulous laboratory analysis. The research team employed a combination of methods to identify and characterize the microplastics found in their Antarctic samples. One method involved filtering the collected water and ice samples through a series of increasingly fine meshes. This process separated the microplastics from other organic and inorganic materials present in the samples. The researchers then examined the filtered particles under a powerful microscope, carefully identifying and counting the microplastics based on their size, shape, and color. To further analyze the composition of the microplastics, the team used a technique called Fourier transform infrared spectroscopy, FTIR. This method identifies the chemical bonds present in a material by measuring its absorption of infrared light. By analyzing the unique spectral signature of each microplastic particle, the researchers could determine the type of plastic it was made from, providing valuable insights into the potential sources of contamination. The discovery of microplastics in Antarctica raises a crucial question. How did these tiny plastic particles end up in such a remote and seemingly pristine environment? The answer lies in the complex and interconnected nature of our planet's oceans and the global transport of pollutants. Microplastics originate from a variety of sources, both direct and indirect. Direct sources include the breakdown of larger plastic debris, such as bottles, bags, and fishing gear, into smaller and smaller fragments over time. Indirect sources include the shedding of microfibers from synthetic clothing during washing and the abrasion of car tires on roads. Once in the environment, microplastics can be transported vast distances by wind, ocean currents, and even migratory animals. These tiny particles can accumulate in the food chain, posing a significant threat to marine life and potentially even human health. The presence of microplastics in Antarctica highlights the global nature of this pollution crisis and the need for international cooperation to address it. Reducing our reliance on single-use plastics, improving waste management systems, and developing innovative solutions for capturing and removing microplastics from the environment are crucial steps towards protecting our oceans and the life they support. Section 5. A delicate balance disrupted impacts on Antarctic wildlife. Antarctica's pristine environment is home to a diverse array of wildlife, uniquely adapted to survive in this extreme and unforgiving habitat. From microscopic krill to majestic whales, these creatures play vital roles in the delicate balance of the Antarctic ecosystem. The presence of microplastics in this fragile environment poses a significant threat to the health and survival of these animals. Microplastics can be ingested by a wide range of marine organisms, from tiny zooplankton to large filter feeders like whales. Once ingested, these plastic particles can accumulate in the digestive tracts of animals, causing physical blockages, reducing their ability to feed, and potentially leading to starvation. Moreover, microplastics can act as sponges for other pollutants present in the water, such as pesticides and heavy metals. These toxins can then be transferred to the tissues of animals that ingest the contaminated microplastics, potentially causing long-term health problems and disrupting their reproductive systems. The long-term impacts of microplastic pollution on Antarctic wildlife are still being studied, but the potential for harm is undeniable. Protecting this unique and fragile ecosystem requires urgent action to reduce plastic pollution at its source and mitigate its impacts on marine life. Section 6. A global crisis implications beyond Antarctica. The discovery of microplastics in Antarctica, a continent seemingly isolated from the rest of the world, serves as a stark reminder of the global reach of plastic pollution. This crisis transcends geographical boundaries and highlights the interconnectedness of our planet's ecosystems. The presence of microplastics in the Southern Ocean suggests these tiny particles are now ubiquitous in our planet's marine environments. This widespread contamination has profound implications for the health of our oceans and marine life. Addressing this crisis requires a collective effort to reduce plastic consumption and develop solutions for removing microplastics from the environment. Section 7. The urgency for action, a collective responsibility. The discovery of microplastics in Antarctica is a wake-up call, a stark reminder that our actions have consequences that extend far beyond our immediate surroundings. It underscores the urgent need for a collective response, a global effort to address the plastic pollution crisis before it's too late. The responsibility lies with each and every one of us. We must reduce our reliance on single-use plastics, opting for reusable alternatives whenever possible. Governments need to implement stricter regulations on plastic production and disposal, encouraging the development and adoption of sustainable alternatives. Industries must innovate, finding ways to reduce their plastic footprint and transition to a circular economy where plastics are reused and recycled rather than discarded. The time for complacency is over. The future of our planet and the well-being of generations to come depends on our actions today. Section 8. Towards a plastic-free future. Strategies for change. Transitioning towards a plastic-free future requires a multifaceted approach, encompassing individual actions, policy changes, and technological innovations. By embracing a combination of strategies, we can effectively reduce plastic pollution and pave the way for a sustainable future. One crucial step is to reduce our dependence on single-use plastics. This can be achieved by promoting reusable alternatives, such as cloth bags, reusable water bottles, and bamboo cutlery. Governments can play a vital role by implementing bans or levies on single-use plastic bags and encouraging biodegradable alternatives. Improving waste management systems is essential for tackling plastic pollution. By adopting a circular economy approach, we can minimize plastic waste and transform it into a valuable resource. Section 9. Our shared responsibility, a call to action. The discovery of microplastics in Antarctica serves as a stark reminder that we are all connected to our planet and responsible for its well-being. The time for complacency is over. The future of our oceans, and indeed our planet, depends on the choices we make today. Let us all pledge to reduce our plastic footprint, make conscious consumer choices, and support policies that promote sustainability. Let us embrace innovation and work together to find solutions that protect our planet for generations to come. The challenge of plastic pollution is daunting, but it is not insurmountable. By working together with a shared sense of urgency and responsibility, we can create a healthier, more sustainable future for all. Let us ensure that future generations inherit a planet where the wonders of Antarctica remain pristine, a testament to the power of collective action and our